Okay, in the last video, what we looked at was a simple Caesar shift cipher, where each character was just incremented by one and shifting it one space to the right. In this video, we're going to look at a variable shift cipher, where each character will be shifted a different amount, and the way we're going to accomplish that is to use a key phrase and find in an offset function. Okay, so let's take a look at a example I got for you, which would be right here and here. Our key phrase is confetti. Our clear text is a very secret message, not very creative at all, I know. And then our cipher text. Okay, so we have a A and a C for input, and we get a C. We have an O and a B for input, we get a J, and an E, we get an R. Now let's take a look at how we accomplish that. What we're going to do is, what we're going to have is an offset values that we're going to sum together. So first we find the distance from the difference between C and A, which is 2, and then we just simply add that to the character A, and that's where the C comes from. The next input would be an O and a V. Find the difference between O and A, which is 14. Find the difference between V and A, which is 21. Now we add the two together, and the sum is 35. So we've outrun the alphabet, right? There's 26 characters, we're at 35. That's where the modulus 26 comes in, because that'll cause it to actually wrap around, and we'll get the letter J, right? 9 spaces past A. Next we have N and E. We do the same thing. Find the difference between N and A, 13. Difference between E and A, 4. Sum them. Mod 26, we get R. Same thing with F and R. So this is the whole algorithm right here. This is everything. This is all we have to do. So let's just look at the code and see how it turned out. And that's right here. Over on the right is just a scratch pad. This is basically just where I started. I just wrote this quick function right here to return the number of blocks in my output. I want 8 character blocks in my output string. So I thought, well, we'll just use a little bit of modulus arithmetic. Every time J is 8, we'll concatenate an empty space to our return string. And then I started looking at our shift function, the shift offset function, and I'm messing around with it a little bit, and then I come to the conclusion, well, if all of our offsets are based off of A, we can eliminate a lot of conditional logic, and so that's what I ended up doing. In our main runner, initialize key phrase confetti, which should actually be passed as a parameter, but I just hard-coded it for simplicity. Initialize our loop, our initial index value for our repeater loop. Okay, so we iterate through the string. Iterate through the string. Here, all characters that are not lowercase are just going to be discarded at this point. We just wanted to make this simple and quick. And the way to do that is just lowercase for input. This is our offset. Call it an offset function. We pass in the C from the string, character from the string, and we pass in the J from the key phrase, our index. That looks like this, right? And this is just exactly the math that we did in the interpreter. Find the difference between the character and A. Find the difference between the character and A. Add the two together. Mod 26. And those are will be passed to the encryption function. Base is A. Add the offset. So that's everything right there. That's all the code. Pretty straightforward. Pretty simple. So what's next? Your challenge, if you're up to it, is to go ahead and write the decrypt function and decode the following here. Now this will be in the description, and if you're up for it, go ahead and give it a try. Put your answer in the comments. If you get anything useful out of this video, give it a thumbs up. Any comments, questions, answers, you know where to put them. I hope you got something out of it. Thanks for watching, and I'll see you in the next one.